Alright, U12s, as promised, I know composite functions is the one that takes a bit of time to understand. It's about the restriction of the domain so that a composite function exists. So what I've done, or I'm going to do, is I'm going to go through some examples that I think you might find difficult and hopefully explain it a bit better. So if you haven't watched the videos in class that I recorded on what a composite function is, please watch that before you do these. I'm just going through the examples and how I would do it. So if you at least got some sort of knowledge of what it is, it makes a bit more sense. Okay. All right, here we go. So, where am I up to? Question 7. The functions of f and g are defined by that. Okay, so you got... I'm always visualizing when I see this. So the first thing I see is I see an x squared minus 2. So it's a quadratic. It goes down by 2. And there's no restriction on any domains. I'm quickly working out the x-intercepts in my head. And that's root 2 and negative root 2. Okay. And then I look at the second one, function of g. It is 0 to infinity, so it's a square root function. So that's nice and easy. Okay, so that's my g function. G of x, f of x. There you go. So those are my two. Sometimes what I like to do as well is for these kind of questions where they say explain why GOF doesn't work or G of f doesn't work, yeah? What I normally like doing, and your textbooks may do this as well, I can't remember if they do or not, is I do this. So I like to lay it out in information. You can do this in your SAC as well. It's perfectly fine. It's nice and ordered. You can say the domain and range, yeah? And this is f of x and g of x. Right, so the domain of f of x, what you can see is one domain, which they tell you already, f of x is R, domain of g of x, which we are also given. It was 0 to infinity. Okay, and now we just got to find the range. Now, clearly looking at this, I knew it went down by 2 for the quadratic, so it's from negative 2 to positive infinity. And then the range for the square root function is also 0 to infinity. Yeah? I like it like that because now what you can say is g of f for a, so g of f, remember this means the function g of f means you've got f of x within function g, okay? This implies for this to exist, okay, for it to be defined, we know that the rate, I'll draw the machine on the side so you remember what I'm talking about. This is f of x, and whatever that is, you're going to substitute it into g of x. Remember that, yeah? So remember, whatever you put in is the domain. What it spits out is the range, which is y values. Now, the y values need to fit into g of x, whatever the restriction is. Okay, and obviously the restriction for a square root function is it can't square root a negative. So that means the range of f, see, I'm looking at this, the range of f needs to fit the domain of g. Okay, and when we say needs to fit, we say subset. Subset the domain of g. Okay, and range of f, which I've already got up here, I'm just going to quickly select it. So range of f, which is this, it needs to fit the domain of g, which is this. So the question is, which we can write this down, we can say, well, this is negative 2 to infinity. Does it or does it not fit 0 to infinity? Okay, logically, well, clearly you are likely to get some negative values here. There's negative 2. And you can tell by looking at the graph as well, you're asking when will the y values, which is the range, be negative, and it's clearly here. This is where the range is negative. We can't have that because when we square root, it can only be positive y values, no negative y values. Okay, so what we want is up here. The only way to get that is if you restrict the domain, but the question's not asking that. The question is just saying, is it defined or is it not? And clearly right here, you know that they don't fit. Okay, so that is not a subset. All right, that's not a subset of 0 to infinity. As you can see, if you draw a number line, it also makes sense as well. Negative 2 to infinity would be like that, and then 0 to infinity is like that. Clearly, this line doesn't fit into this. But what does fit is the 0 to infinity fits into -2 to infinity. So if it was the other way around, if it just so happens to be the other way around, of course it would have worked, but in our case it doesn't, right? So that's where you then say, therefore, you should, well, normally in a SAC, this is what you should actually say. For G of F to exist, range of F must be a subset domain of G, and so therefore gof F does not exist. Okay. I wonder if they ask you to restrict it. No, they don't. Well, normally, let's say if the question, I'm just going to do a bit of a tangent now. Okay, so let's say if we know G of F doesn't exist, then now you say, the question normally says, then restrict the domain so that G of F does exist. So you want it to exist, because right now it does not exist. So then how would you restrict the domain so that it does work? Well, clearly, from the quadratic, from f of x, so f of x, the values that you can choose to put in, okay, you have to restrict that, because initially it had no restriction. It said you can take anything you want. It's R. So for it to work, you're going to have to fix this problem. Okay. So the question is, how do you restrict the domain so that you can have what you want? And clearly, the only part that you can substitute in, which I'm just going to quickly highlight. Oh, it's actually up here. This is what you want. And the domain for that, if you had just fixed the domain and just said, instead of this, we can now say the domain that we want has to be x needs to be less than or equal to -√2, or x is greater than or equal to √2. Okay, how you would normally write that is you'd say, you know, -∞ to -√2, including union √2 to +∞. That's how you would restrict the domain, because that will ensure you will always get positive y values. Here, all the coordinates are always positive y values. If it's always positive y values, if this is always positive, then all the numbers that you square root are always going to be positive, therefore G of F exists. Okay, so if that's the question they normally ask, then that's how you do it. Okay, but this question says, find f of g and sketch its graph. So f of g, let's do b now. So b is f of g, which means I'm going to substitute g of x into f. Okay, and g of x is a square root function, and I'm substituting into x squared minus 2. Okay, so usually I'd have x squared minus 2, but instead of the x, I'm now substituting g of x in, so that makes it root of x all squared minus 2, and that ends up being, what's that, square root, so x minus 2. Okay, now you just got to be careful here. Yes, because when you sketch the straight line, don't just jump to the conclusion and say, all right, well, that's a -2 y-intercept, and therefore you get a straight line equation, and the x-intercept is 2. Yeah, don't do that, because there are restrictions that we got to look at. Okay, so drawing the machine on the side again, you got g of x, and you got f of x. Now g of x is a square root, this is an x squared minus 2, so what can you put into the first function to begin with? The restriction already told you it was 0 to infinity. So there's a restriction already. The domain that you put in, domain of g, you already put in only between 0 to infinity. True? Those are the only numbers you choose. You wouldn't chuck in a -1 here, because then it'll never spit out a y value. True? And then f of g wouldn't exist. So you naturally already have a condition. And the condition is 0 to infinity must work for the first one. So that means when you sketch the graph, well, it doesn't make sense that I have now negative values. How am I having negative x values when clearly the numbers I'm choosing are only going to be 0 to infinity? So you're only going to be sketching the graph 0 to infinity, because we know that x squared minus 2 has no restrictions. It can take any y value that you happen to be able to spit out, any y value that you spit out, it can take. Okay, so given the restriction that you have, the graph that you sketch can only now take it from here onwards. Now you can take a 0 into the equation, so therefore it is inclusive. So that's what the graph should look like for g of f. I mean f of g. Okay. There we go. So that's part B in sketching. So every time you get the equation, you just gotta double check that the restrictions work. And I like drawing this diagram because I think it makes more sense. Okay, so draw the diagram if it helps you. Yeah. If you're a bit more proficient, then you don't need to, but it's always important to get your domain and range correct. That's what separates the top kids when they do the Saxon exams, is whether they're paying attention to the notations, which is the range and domain. Okay, because that's generally overlooked. Let's have a look at question 8. Okay, so now I've got a straight line. F of x is a 3 minus x, and I've got g of x, another quadratic. Okay, cool. So right now, I've got negative x, 1 is up to 3, and it goes down, so it's 3. So, and it goes negative infinity up until 3. Ooh, so the graph stops here. Okay, so that's for f graph. I'm just looking at the domain. Negative infinity up until 3. That's my domain for the first graph. And for my second one, I have no restrictions. X squared minus 1. So minus 1, 1, and 1. Negative 1. Alright. And same thing. Show that f is not defined. I always do prefer to do it like this. You can choose not to. I don't mind. You do what you want. Okay, I'm just laying out the information. Especially if I'm doing a SAC, I don't want to screw up. Okay, so you got your domain, you got your range, you got f of x, you got g of x. Clearly the domain they already gave it to you, so negative infinity to 3, and the other ones are. Now the range, clearly if you can picture the graph, the range is 0 to infinity for the first one, and the second one is negative 1 to infinity. Okay, now the question A asks you to show that f of g is not defined. So f of g really means I'm going to substitute g of x in. Okay, so I'll draw the machine on the side again so that we understand what we're doing and how I know or how I remember. Okay, we're just saying whatever number you chuck in, it will spit out, so an x value you chuck in, it will spit out a y, which is the range, and the range needs to fit f of x, whatever the domain or the restriction is for f of x. Okay, and the domain restriction is it can't take any. Oh well, it can take any value, but as long as the number that you chuck in, because remember there's a condition here. This is the domain. It says that it has to be negative infinity to 3. So as long as the numbers are from negative infinity to 3, we're all good. Okay, that's what we're looking for. So. What I'm effectively saying is range of g, because that's the y values, that's the range of g. Range of g needs to be a subset of the domain of f. Now the domain of f we already know. I'm going to use another color. Domain of f we know now is negative infinity to 3. Range of g, which we look over here, and it's negative 1 to infinity. Okay, and now you ask yourself, is that a subset? No, that ain't a subset. If you think of it as a number line, negative 1 to infinity will look like that. Okay, and then negative infinity up to 3, let's say 3 is over here, it would be like that. Okay, so you can see it's not a subset. So therefore, so here you always got to say for f of g to exist, range of g must be a subset domain of f, therefore f of g of x does not exist. Okay, so I've done question 8a. Now let's do 8b. Let's go to 8b. Why are there so many emails? Holy cow. It must be, I reckon Miss Vinicum is up and ready to work today, which is great. You know, I'm working too, but don't normally get this many emails on a Sunday. Okay, so let's see. What's the next one? Oh, define a restriction. Okay, so obviously it doesn't work. Now you gotta restrict it so that it works. Okay, so what are you restricting? Your aim is that you want the range of G to fit the domain of F. That's what you want. Okay, so at bare minimum, it maybe you just gotta you just gotta cap the upper limit here. Okay, so if you think about it, I'll draw the number line again so you see what I mean. -1 to infinity was from here to here. Yeah? Whereas this one's negative infinity up until 3. So let's say 3 here. So it's this way. True? So the only thing that isn't working is the -1 to infinity. It keeps going on. So if you can just keep it from -1 up until 3, if you just make sure that the range ends up being like that, that's good. It fits. Okay, so your goal is to make sure that the range of G will only sit between -1 to 3 maximum, 3 being the max. Okay, so what you want is instead of this being infinity, you want it to be 3. Okay, so how do you do that? Let's look at the graph. Range of G, so G, which one's my G graph? This is my G graph. Okay, that's my graph. And I want it -1 to 3. So effectively, I only wanted the range to only go from here to here. I don't want any more. Yeah, so that means I need the X values that correspond to that. I need to know what numbers can I substitute in. I'll do another color actually. Oh no. Here we go. I'll do another color. All I'm saying is, I just need to make sure when I choose my domain, I have to make sure I get maximum of y equals to 3. That's what I want. Okay, so the question is, what's the domain? What's the restriction? Okay, because currently I have no restriction. Currently I'm like, take any number. But obviously it won't work. So I need to restrict this domain so that it works so that I get a value of 3. So the question is, how do I get 3 as my y value? So this is my 3. I want to get a 3. So really you're trying to solve for x squared minus 1. And you solve it so that it becomes what? 4 equals x squared. And you find out that x is equal to plus minus 2. Okay? So if you sub in 2, so 2 squared is 4, 4 minus 1 is 3. So you know now the limit is that you only get from 2 to -2. That's your domain. So instead of R, you now know you can choose -2 to 2. Okay? Oh, actually, let's be careful. Can I have 3? Yes, I can. So it has equals to 3, so I can have 3. Okay, sometimes if that was an open bracket here, then you got to make sure these two are open brackets as well. So that's what I mean. You just got to be careful with these domains and range when you're doing these questions. Okay, so I've effectively, what I just did is I just answered the question that the domain of the new G should be x element of -2 to 2. There you go. And that will make it defined. And it makes sense because if the domain is this, you will end up getting a new range for G. Okay, it's -1 to 3. That's what I'm trying to say. So watch this one again if this part here is confusing, because that's what you're required to do. I will actually, I think there is on the resources tab, I think there is an exercise just purely on composite functions. I'll give that to you tomorrow, and I'll upload it as well, and you can practice these kind of questions, yeah? But they're important. Now I'm going to do 11. So same thing. Let's have a look at 11. And then I'll do 12. And I'll call that It's for Today. Yeah? Let's see. Question 11. Let F... okay, so you don't know what the domain is. But you know the function. That's a circle. Whoa. That's a circle function with a radius 2. It's a semicircle. Because it's a function. Remember functions and relations? Because it's a function, because that's function notation, we know that it's a circle, a semicircle, radius 2. So it actually, and it's positive root, so it's on the top half. 2 to 2 and 2. All right, so I got my picture. I understand what it looks like. It's defined by, okay, so you get another one where g of x is x squared plus 1. So this is f and this is g. Okay. Plus 1. So there's no x-intercepts. It's always positive. Okay, cool. Find s. Well, I just actually, see, this is what I mean. Once you understand graphs, you know, it's all in chapter 11. When you answer the question, the more you can picture what it is, it makes it easy, because the first one is find the domain, find s. And because I've drawn the picture, it's really easy. S obviously has to be equal to -2 to 2. Okay, because it's a semicircle. And then find the range of f and the range of g. So, well, because I've drawn the picture, it's clear that the range of range of f, sorry, would have to be, so I'm doing b now. Range of f, looking at the graph there, it's clearly from 0 to 2. So, 0 to 2. Okay, and range of g, if you draw the graph, it was clearly, it's from 1 to infinity. Any restrictions in the domain? No restrictions. So 1 to infinity. Okay, there you go. And then C. State whether or not f of g or g of f are defined and give a reason for each. Okay, so every time I'm doing these kind of questions where you got to define something, whether it is defined or not, I like to do, as I said before, I like to do this. You got your domain, you got your range, you got f of x, you got g of x. Yeah? Now the domain was already sort of solved. We know that this is, I'm going to do another column so we don't get confused. This is -2 to 2. G of x, which they told us was r. And the range we all figured out, that was 0, 2. And this was 1 to infinity. Okay. There you go. So for f of g to exist, we know that range of g, because it's what you're substituting in, yeah, g you're subbing into f. So range of g needs to fit as a subset of domain of f. Okay, so let's answer that question. Range of g, which is 1 to infinity. Okay, is it a subset of the domain of f? The domain is -2 to 2. And no, that is not a subset. 1 to infinity, and that starts at -2, so no, it's not a subset. Therefore, f of g is not defined, or not exist, is not defined. Then you try g of f. Okay, g of f, so same idea. This means that the range of f needs to be the subset of the domain of g. So if we do that, domain of f, which we already got, range of f, which we got as 0 to 2, and it needs to be a subset of the domain of g, which is r, and clearly it's a subset. Therefore, g of f is defined. Okay, I'm hoping like you're starting to pick up the sort of gist of what I'm doing. The hardest one is, like I said, it's this one. It's where you have to restrict the domain. Part B. That's the one I really wanted you guys to sort of do. Wait, I just realized I didn't answer the question properly. It says define a restriction of g such that f of g is defined, and then find f of g. Oh, sorry. I'm going back to this one. Remember what, and this is what I just did was a classic example of what students do in a SAC. They forget to answer the question properly. It says defined and find. So I already defined it, but I haven't found the answer. And remember I said when they tell you to find a rule, when they ask you to define a rule, I said you must write it as a function notation, meaning it has to be of this form. Okay? Now because they're using the star, I'm going to do it as well. I'm going to do f g star colon. The domain that we worked out had to be -2 to 2, right up here. Okay? Maps onto R, and now f of g of x, okay, is equal to, and do we find out what that was? No? Oh, okay, we're just saying you're substituting x squared minus 1 into f of x. So in that case there, we've got 3 minus, instead of x, is now x squared minus 1. And that becomes, what, 3 minus, wait, negative plus 1. So it's 4 minus x squared. 4 minus x squared. There you go. Okay, that's the proper way to answer your question when they ask you to define. Okay, I noticed there's a little mistake in my notation as well. I wrote f of g star, so this one should be a star there. There you go. Okay, and we just did 11. Okay, now we're going back to 12. Moving on to 12. Last question. Woo! All right, let a be a positive number. Okay, so a is a positive number. I'm just going to write there. A is a positive number, so it's greater than 0. Let f be, okay, so this is a function. Restriction is 2 to infinity, and f of x is a straight line, and it's a negative gradient. Y-intercepted a. That's interesting. So what they're really trying to say to me already is I've got negative gradient. Y-intercepted was meant to be at a, but it doesn't reach there because the domain goes to 2. But who's to say that 2 doesn't give you the y-intercept? No, because this is where x equals 0. Okay, so 2, it's restricted at 2, and it's included 2, and it goes on. So this is what the graph roughly looks like, hypothetically. Okay, I just don't know what a is. A is a positive number, so it could be 1, 2, 3, 4, whatever it is. So a is the y-intercept. But I just know, because of the restriction, it looks kind of like this. Okay. The second one, let g negative infinity to 1. Okay, another restriction, where g of x equals to x squared plus a. Ooh. Okay, so g of x squared plus a, and a is a positive value, so that means it has to be above the x-axis regardless. Okay, it's a quadratic, and it I just made a mistake. It goes from negative infinity to 1. Okay, so negative infinity to 1, and it's inclusive, so it's 1. Okay, so let's find out the y values. I'm just going to try to get the endpoints here. So when x equals 2 for the first equation, when f of 2 will give me a minus 2. So that means here, when x is 2, I get a minus 2. Okay? And over here, when this is 1, the endpoint's 1. So g of 1, I get 1 squared plus a. So it just becomes 1 plus a. Okay, so this coordinate here, when x is 1, y is 1 plus a. So it's 1 plus a. Okay? This is a minus 2. All right, cool. All right, so cool. So I've got my pictures. Now the question is, find all values of a for which both f of g and g of f exist. Now, anytime that you need something to exist, remember I said what I would do is I would find out the domain, find out the range. I've got f of x, I've got g of x. Now, because I've drawn the picture, it's a bit easier now to have a look. Clearly, the domain which we've been given as 2 to infinity for the first one, and the other one was negative infinity to 1. Okay. Range, which from the pictures, it was clear, I can see it. It's a to infinity for the first graph. Okay, so, I mean for g of x, it's a to infinity, so g of x is a, it's inclusive of a to positive infinity. Whereas the range of the second graph, because it's a negative gradient, goes down, so it's from a minus 2. Oh no, negative infinity to a minus 2, sorry. Gotta fix this. There we go. Negative infinity to a minus 2. Alright, now that I've got that, so we want f of g to exist. So f of g to exist, we need range of g, because it's what you're substituting in, to be the subset of domain of f. Okay, so range of g, if we have a look, range of g, a to infinity, needs to be a subset of the domain of f. Domain of f is 2 to infinity. Well, that's pretty easy. The only way for it to fit, they're both going towards infinity, and a needs to be a minimum of 2. It could be anything now. But because the question says find all values of a, so the best values are a can be any value. So if I draw out the number line so you know what I mean, this condition says it has to be from 2 to infinity. Now for a can be any number. A is a positive number, and a needs to be a subset. So a could start here, or a could be a subset where it starts here. See that what I mean? So therefore a clearly just has to be bigger than 2, or equal to 2. There you go. In that case therefore f of g will exist. Hope that makes sense. Okay. Next one, g of f. In this case here, to exist, range of f needs to be a subset of the domain of g. Okay, so it's the other way around. And we can see the domain of f, which is 2 to infinity. Wait, that doesn't make sense. Yeah, no, that's the domain of f. Range of f, which is negative infinity to a minus 2, needs to be a subset of the domain of g, which is negative infinity. So they're both negative infinity, and they're going to 1. So if you have a look at the number line again, negative infinity up to 1. So you've got this thing. You need a minus 2 to fit this. Now that means as long as a minus 2 is less than or equal to 1, it will fit. True? So that's literally what I'm going to write. A minus 2 needs to be less than or equal to 1. And it'll work. Because whatever a minus 2 is, I can't have it being more than 1. Then it won't be a subset. So if you do your inequations here, just add 2 on both sides. And as long as a is less than or equal to 3. And it works. So 3 take away 2 is 1. And then 2 take away 2 is 0. It all fits. Yeah? So there you go. Therefore, when a is less than or equal to 3, therefore g of f will exist. Now, be careful. We haven't answered the question. They said find all values of a for which both f of g and g of f to exist. So here's a problem. In one hand, we say that a needs to be greater than 2. A needs to be greater than or equal to 2. And on the other hand, they say a needs to be less than or equal to 3. So if I draw a number line, it's pretty obvious here. So 0, this is 2, this is 3. One says you need to be greater than, a needs to be greater than or equal to, for f to work, for f of g to work. Was it f of g or was it the other way around? Yeah, f of g. And then the other one says it needs to be less than or equal to 3 for g of f to work. So what should a be so that it works for both? Here we go. Any numbers between 2 and 3. So if a is between 2 and 3, both functions will work. That's where they both have in common. True? That's question 12 there. Hopefully you feel much better with composite functions. If you haven't been watching it, I will tell you in class to watch this one because I think I've covered it pretty well, providing that you have understood the first video for exercise 1E. Okay. Thank you. Enjoy your Sunday. I am now going to do some PowerPoints, prepare myself for our sessions, our coming sessions, because we got to catch up. I've lost so many sessions with you guys. It ain't funny. So, got to prepare some lessons. All right. Enjoy.